Welcome to Analytically Delicious, Insights into Food Safety by LVA. Join us as we explore the latest developments, trends, and challenges in ensuring the safety of our food supply through analytical techniques, uncovering the science behind what makes our food safe and delicious.
Welcome to our third episode of Analytically Delicious. I'm your host, David Steiner. In our first two episodes, we explored pesticides and mycotoxins, highlighting the distinct mitigation strategies for these substance classes. Today, we broaden our focus to encompass risk management and food safety on a broader scale. These areas are crucial as they directly impact public health and consumer confidence. Incidents like the 2011 E. coli outbreak in Germany or the 2008 melamine contamination in Chinese infant formula and the 2013 horse meat scandal in Europe underscore the necessity for rigorous safety protocols in the food industry. Our guest today is Rudolf Krska, a renowned professor at BOKU, where he leads the Institute for Bioanalytics and Agrometabolomics at the Department IFA Thurn. Additionally, he is a professor at the Institute for Global Food Security at Queen's University in Belfast. Throughout his impressive career, he has also served as a managing director of the Food Research Division at Health Canada in Ottawa. For the last 7 years, he has also been serving as a key researcher for the Austrian Competence Center for Feed and Food Quality Safety and Innovation, FOQSI, in Thurn. Alright, Rudi, this one's just for fun. Remember the horse meat scandal in 2013? Do you think we will ever reach a point where our food labels can guarantee that we are not accidentally serving up a mystery meat burger at dinner?
Well, nowadays a mystery veggie burger does seem equally likely, doesn't it, David?
Absolutely.
Yeah. But regardless of whether it's a mystery meat or a veggie burger, such events clearly weaken the consumer's confidence in food safety. By the way, to mitigate the problem of this issue, a knowledge center for food fraud and quality was established in the European Union, which collaborates closely with Europol. And David, as you are aware of my passion for analytical chemistry, I shall also point out that accurate control and modern analytical methods are crucial to prevent any fraud along the food chain. However, having said that, it would be naive, clearly, to believe that such cases will no longer occur.
Absolutely, fully understand and agree on that.
Yeah.
Switching gears now and to a more serious note, Rudi, can you share personal experience or anecdote that significantly influenced your approach to food safety research? Perhaps a story from your time at Health Canada. I think that would be very interesting for our listeners.
Well, it's probably not an anecdote with an happy end, but it's more like a story. So I can tell that I was particularly impressed by the melamine scandal, which popped up when I applied for a job as acting chief of Health Canada's Food Research Division back in 2008. Actually quite exciting for me as a personal experience. As you know, in this case, in the melamine case, the cheap substance melamine was added to infant milk powder in China to increase profits. So it was a pure greed thing. As you know, for the sake of simplicity, the protein analysis of milk products is often determined through measuring the nitrogen content from which the protein content is calculated. So roughly, I think, about a factor of 6. Since the melamine molecule contains a much higher proportion of nitrogen than milk protein, and I think you're aware of the structure as my former PhD students, I hope so. The addition of this chemical can simulate a false high protein content in the milk powder during the product testing. And well, as a result of that, the addition of melamine made it possible to achieve a much higher price on the market. So tragically, and that is something I guess those who were responsible for this massive fraud case have not been aware of. The ingestion of melamine led to the formation of kidney stones, especially in small children and infants, which resulted in numerous hospitalizations, even deaths in China. But also Europe and particularly North America, including Canada, were affected back then. So this is why Health Canada's Food Research Division, of which I was in charge of in 2009 and 2010, was extremely busy developing the first validated method for the sensitive determination of melamine and similar compounds at trace level. So actually experiencing this challenge has been a motivation and I would also say inspiration for me to immerse myself even to a great extent into organic trace analysis in the food arena and also to develop sensitive methods which can ideally cover the entire set of all all classes of contaminants, group in food and feed, to be ready, so to speak, for the next scandal, which hopefully is not going to be occurring soon. But that has really been like something which served to me as I said before, as inspiration for my work, especially also when I returned from Health Canada back to Europe.
It sounds also like a very turbulent time this year, and you also mentioned already one very important point, namely analytics, but we will come to that point a little bit later. I would like to move on now into other specifics. Rudi, how is risk assessment conducted in the food industry, and what are the primary factors considered?
Yeah, well, that's something which is particularly in the European Union pursued in a highly professional way, but it's a complex approach which is used to assess food risks. I would say European Union is among the world leading areas where risk assessment is really performed at the perfection level. It starts with the identification of the potential hazards. So I would say, well, now summer is coming. Maybe you might see a shark. It's definitely a hazard, right? I think you don't have to know anything about biology, don't have to know anything about chemistry, etc. So it is definitely a hazard. How can we, however, assess the risk of for example, a newly discovered substance, such as the recently discovered Fusarium mycotoxin NX2. So hardly anybody knows about it. And from the mere structure of the molecule, you cannot tell whether this is a hazard, and also whether there is any associated risk with that particular molecule. So that is why, after this identification of a hazard, and how is actually that being done, that we as researchers, and you have been among our team as well, or you at LVA, you will identify a new molecule which is a potential hazard and also a potential risk. That is why you need a second step, and that is to determine the exposure to this either fungal metabolite, such as the Fusarium mycotoxin, or a new pesticide which comes on the market. For shark, it's again quite easy. Well, if you stay or you spend your next holidays in Austria, the exposure to a shark is probably nil. Maybe you go to the House of the Sea in Vienna, but you're still safe. So again, this situation is much more complex in the area of chemical contaminants, where we need then analytical data on the occurrence of this substance in the food chain, for instance, in grains when we're talking about mycotoxins. And also we need to know about the frequency of the intake of that potential toxins via the food. So to summarize, we need to have a survey with occurrence data, and we also need the information on the consumption data, and then the exposure can be calculated. And then comes the third step in the assessment of a potential food safety risk, and this is the toxicological characterization of the hazard. This final step is, however, bad news, an extremely difficult and time-consuming undertaking, which involves extensive tests, such as on cell cultures, and unfortunately still also on animals. That's still required. So finally, when all these data for the assessment of a potential food risks are on the table, institutions like the European Commission can make a decision, for instance, on setting a maximum regulatory limit for instance, aflatoxin B1 in peanuts. In Europe, actually, we have this identification of the hazard, which is rather done by DG Health and Consumer Protection, DG Santé, right? They are the executive, so to speak, and they will then ask when such a hazard, as in this way which I've just described, has been identified. They will ask the European Food Safety Authority, EFSA, to come up based on this three-step process with a scientific opinion, whether or not, for instance, a regulatory limit which regulates the maximum limit of this particular compound in food shall be established as well, and which kind of management measures are needed to ensure that these regulatory limits can be obeyed with.
Yeah, great. Thanks for these insights. And now that we have already covered the basics, could you elaborate on the differences between the maximum levels for pesticides and mycotoxins. The reason why I'm asking, our first two episodes, we talked about these two compound classes. And can you maybe also show us the significant variations in the toxicity levels?
Yeah, well, talking about toxicity, I mean, I've just alluded to this complex process, and that toxicity is really the bottleneck. It's a very lengthy process, as I've just depicted, from the identification of a new substance, such as a mycotoxins or a pesticide, to the final risk assessment of this potential chemical hazard. And toxicology indeed remains the major bottleneck of this process, but clearly the consumer is not only interested in the occurrence data, consumption data, but also on what does the occurrence of these contaminants mean from a toxicological point of view. And consumers are particularly critical about pesticides. There has been a lot of fuss about pesticides. Well, they are ubiquitously occurring, so there's clearly a reason for that. There's been glyphosate, etc., in the media. So, however, I would even go so far, actually, from my perspective, as to say that we now have, I would say, distorted perception of the harmful effects on health of those chemical substances which have been tested most extensively. That is namely pesticides. So mycotoxins, however, are hardly noticed. When you go on the street, ask people for mycotoxins. Maybe some have heard about aflatoxins, but that's it. However, fungal toxins, mycotoxins, are usually much more acutely toxic and often also genotoxic carcinogen, which is really on the top of the toxicity scale than pesticides by a factor of 100. So some mycotoxins, as I said, are even genotoxic carcinogens, which is for sure not the case for pesticides, which are kind of already ruled out at the very beginning of the selection process. So to give you an example, tebuconazole is a fungicide, a subgroup of pesticides which is used to combat fungal invasions such as with Fusarium. So the LD50, so the lethal dose, which 50, which is an indicator for the acute toxicity of tebuconazole, is 5,000 milligram per kilogram body weight. So I don't want to become too technical. However, that shows already that this substance is obviously not very toxic. When you compare that with the most prevalent mycotoxin we've got in Austria, deoxynivalenol, or in former times it was also called vomitoxin because it causes vomiting, has an acute toxicity with an LD50 of 50. So a very low dosage of deoxynivalenol compared to tebuconazole suffices actually to kill the mice in this LD50 experiment, which means 50 versus 5,000 of tebuconazole, or let me put it the other way, the mycotoxin is a factor of 100 more toxic than the tebuconazole, which is used to fight deoxynivalenol, to fight Fusarium, which is producing deoxynivalenol. On the other hand, for deoxynivalenol, which is much more toxic, we allow a level which is about 25 times higher than tebuconazole as the maximum regulatory limit. So does this make any sense? No, because we allow a substance which is actually much more toxic to occur at higher levels, whereas vis-a-vis with a pesticide, which is very low toxicity, we allow only very low levels. However, clearly a pesticide is something which we can decide tomorrow to abandon, to regulate the use of pesticides, that we are not going to use any pesticides anymore. Certainly there will be consequences, particularly for the quality of the food, for the harvesting yield, etc. So there comes a price with it. Certainly for mycotoxins, we have to accept higher levels because mycotoxins cannot be completely eliminated. We cannot make a political decision as of tomorrow to eliminate mycotoxins. So that explains why we are much more mindful and much more strict with pesticides than we are with mycotoxins. But from a toxicological point of view, from a risk assessment point of view, this decision is, to say the least, not really the correct one.
I understand. And on the topic of safety, Rudi, how do economic factors now influence the food safety regulations? Are there any trade-offs between economic feasibility and ensuring maximum safety?
I mean, when we stick to the example of pesticides versus mycotoxins, if we were to set the same strict limits in terms of maximum regulatory limits for mycotoxins as for pesticides, we would not be able to put bread and pasta products on the market. We would not be able to have any bread on our table because they will be contaminated at a level which is higher than those of pesticides. So mycotoxins will be on your table, will be in your pasta, will be in your bread, but certainly also the dose makes the poison, as we know also from Paracelsus. But that is something which is still a little bit irrational, but we have also to perform a reality check, and that I think accommodates your query a little bit more on the spot. That once, for instance, the European Food Safety Authority or other institutions like Health Canada, like the FDA in US, etc., come up with a recommendation for a maximum concentration level as the maximum regulatory limit for that particular contaminant in the food. They will ask before it is implemented or executed, they will have a check for the economic consequences for that decision, and they will also make, usually also during my time at Health Canada, they will organize, let's say, a conference call meeting with the industry and see whether these ideal limit values figured out, devised by scientists, can be complied with at all without actually having to give up food or to sacrifice economically too much. And this topic is certainly particularly pronounced in the global south, which experiences massive contamination, as you know, for staple food with mycotoxins. So if we were to apply the same strict limits we have got in Europe as to the global south, such as sub-Saharan Africa, there would not be any bread on the market. Yeah. They would not be able to consume any of the maize products. So it depends from region to region, and it is also something which has to be taken into consideration. For trade-offs and economic consequences, it's also interesting to point out the pistachio case in Iran. I find that's quite interesting because there's a lot of complaints, certainly about industry, when they are to invest a lot of money into, for instance, pesticide control, mycotoxin control, etc. So in Iran, they had a problem with aflatoxins B1. Well, there is still the challenge there. And they were obliged then, especially by the European Commission and other areas in the world, to devise a quality control skill with hazard analysis, critical control point analysis, to produce high quality pistachios containing ideally lowest or no levels of aflatoxin B1. This was certainly a major undertaking for Iran. They had also to invest a lot of money in order to realize this project. But in the end, they were able to achieve a much higher price on the market with their top high quality product on the market. So there was even a trade-off that they have now top pistachios on the market. This, according to the literature I'm aware of, has not been true for US almonds. So the almond case in US is like, a no trade-off case where a lot of money was invested, and obviously there was not such a trade-off, but this may have changed in the last years. But certainly it's also consumer awareness which has to be taken into consideration. There is all these consumer magazines reporting about concentration levels of contaminants in food and food products, and certainly the top food producers certainly want to be at the top of the list of those products which contain the least or the lowest levels of contaminants and the least number of contaminants. If you were a manager of, Barilla, we have a great collaboration with them, certainly you invest a lot in research, and you would like to come up at the top of the list of the least contaminated. And that is also something which is appreciated by the consumer, often even to a level which is not really, when we're not talking about healthy or unhealthy levels, because we are talking, well, if the regulatory limit is, let's say, a 700 microgram per kilogram for contaminant, whether it's a 100 microgram left or a 50 microgram, it's far below 700.
Yeah.
So there's also a psychological topic associated with that, but that's fair enough. But that's also something which the big food producers have to have on the radar.
Yeah, sounds very impressive, and it also looks quite comprehensive, the whole process to keep our food safe. And in this relation, Rudi, I have a follow-up question. As I already mentioned in the introduction, you are head of the Institute of Bioanalytics and Agrometabolomics at IFA Tulln, well known for its interdisciplinary nature and also the I would say, worldwide leading mycotoxin competence center. So how crucial is interdisciplinary collaboration in addressing food safety issues? Could you share an example where such collaboration led to a significant advancement in food safety?
Right. I mean, that is definitely something which I'm very happy to accommodate in almost any area in science. Their interdisciplinary research has become crucial, and that is also true for food, and that is particularly true for mycotoxins. That is why I kind of have maintained my passion for that particular type of analyte, if I may say so. And let me say that the Inter-University Research Department for Agrobiotechnology, IFA Tulln at BOKU University, I think is indeed a role model for the success of such interdisciplinary research. And that is particularly true for the research goal to mitigate mycotoxin in the food chain. So as you know, we are talking about toxic secondary metabolites of fungi. Why are they produced? Mycotoxins are produced when the fungi is stressed. The fungi then switches not only under drought conditions, but especially also when it runs out of nutrients, especially when the plant is at blossom. The fungi will then switch to its secondary metabolism under stress, produce their poisonous arrows, so to speak. So they will inject their toxic substances, mycotoxins, into the plant, weakening the immune system of the plant, and then the weakened immune system of the plant is then certainly good for the fungus. It can get again the nutrients out of the plant. So that's bad news for the plant, but it's also bad news for animals, and that's also bad news for us humans. And that is why we're talking about an interdisciplinary challenge here, because we have to collaborate with plant pathologists. So we have a long history and a strong history, as to say so, at IFA Tulln, where plant breeders at IFA Tulln have been breeding for the last 30 years resistant genotypes of maize and fungi to have already the resistance on the field, so that actually the invasion of the fungus on the field can be prevented to the extent possible. Within this effort of the resistance breeding, certainly some that has to be chemically verified. So we need also to verify that the reduced infection also results into reduced levels of mycotoxins. This is where we as chemists come in, so that we have been having collaboration between the plant breeders at IFA Tulln with the chemists at IFA Tulln Institute for Bioanalytics. And then comes in, well, how can we mitigate the issue then not only pre-harvest with resistance breeding, but also post-harvest by, for instance, identifying, selecting microbes which are able to detoxify, inactivate mycotoxins. That has been a success story with our company partner Biomine at the campus Tulln, identifying microbes, but also isolating enzymes, also coming up with recombinant enzymes, which can then be used as feed additives. So these feed additives being added to the feed and are then also reactivated in the gastrointestinal tract together with also the mycotoxins, but the mycotoxins are then then inactivated by these enzymes in the gastrointestinal tract. So that also needs biomarker analysis, biomarkers of effect to verify really is there any effect. We have to also to get the license for these feed additive. The potential metabolization products have to be specified, and also as I've alluded to before with Barilla. So we have the thermal fate of mycotoxins during baking. Has to be studied, ideally to degrade, to further reduce the mycotoxin level, for instance, in pasta, biscuits, crackers, whatever. But you also have to, at the same time, to verify that the mycotoxin metabolization products or degradation products are less toxic than the parent molecule. Well, because it's also possible that there is a more toxic molecule as a result of this degradation process. So that is from the plant biotechnology to enzyme technology to chemists involved to also certainly veterinarians who have to be present to verify on the animal, with the animal, cattle, chicken, swine, whether these feed additives are efficient. A role model, as I've already pointed out before, for the importance of interdisciplinary research, but also for the success of interdisciplinary research, especially in the area of food and feed safety.
That's very interesting. And before we move on, I have to mention that our guest today is not only a leading scientist, but also something of a rock star and also a book author. So check that out.
Toxins in food are not okay. It's why we research all the way. BON and HT2. There is still a lot to do, so let's rock. Everybody, let's rock.
When can we expect to see you rocking on the stage? And should James Hetfield be worried about his career now?
Well, I think the latter is something which I can say no, but it has been great fun actually. So we had this Ready for Scandal rock band, and we got really inspired, and then we came up with these some of the verses like toxins in food are not okay. That's why we research anyway, and some toxins are not recognized because they are metabolized. That's why we need mass spectrometry subsequent to HPLC. So let's rock. So it's this well-known Elvis Presley song "Jailhouse Rock," which we have used for this purpose. So it has been a great fun. It actually is also testifies to the fantastic atmosphere we have been having at IFA Tulln. And but I'm usually specialized in Georg Danzer songs. So sometimes you will see me on stage with that, but we will have the next gig in October, celebrating the 30th anniversary of IFA Tulln. Perfect. We will be there, and there will be also some updated version of the Toxin Rock.
Looking forward to that,
I hope you will be there.
For sure. So Rudi, we have discussed about pesticides and mycotoxins extensively. Can you give us maybe an estimate of the total number of contamination sources in our food supply chain? How do these various sources impact risk assessment and the management? Yeah,
I mean, that's a big question. And I think you told me at the beginning of this little podcast interview that we shall not exceed 1 hour.
True.
Interview time. So that is why I suggest to present these chemical contaminants in a little bit of a different way, rather than kind of providing you with an endless list. So let us distinguish rather between intentionally and unintentionally present chemicals in our food supply chain. So first of all, there is these intentionally used chemicals which are purposefully present in the food, such as food additives. Well, so So it's an intention. We add this food additive such a preservative to increase the shelf lifetime of the food, for instance. And so it's definitely a purposefully present chemicals. So this is something which has also, in another context, another group of chemicals which are intentionally used chemicals, and which, however, not purposefully present in the food when eaten. And these are, for instance, pesticide residues, veterinary drugs. So we have these intentionally used chemicals which are purposefully present, and there is intentionally used chemicals which are there, but they are not purposefully present in the food when they are eaten. This is why we're talking about pesticides, about residues, right? A mycotoxin is not a residue because we are not intentionally adding the mycotoxins. It's there because it's a natural toxin produced by fungi. We are purposefully adding the pesticides, but we have to live with the fact that there are sometimes residues and this shall not exceed the regulatory limit. However, also these intentionally used chemicals which are purposefully present, such as pesticides, are, according to European food safety, not expected to cause human health concerns as long as the concentrations are within the legal maximum residue levels of food. And that is why it's very good to have these EFSA opinion and the regulatory limits, which we can use to compare these with the levels we found in food. And then there's the third group, where we're talking about unintentionally present chemicals in the food, for instance, environmental and food process contaminants, such as acrylamide, such as polycyclic aromatic hydrocarbons, and natural toxins such as mycotoxins, algal toxins, plant toxins, etc. So these unintentionally present chemical contaminants in the food can pose, according to European Food Safety Authority, public health concerns if their concentrations are not, or, and that's different to pesticides, or cannot be kept at appropriately low levels as dictated by legislation. As we've discussed before, mycotoxins can sometimes not be kept at the appropriately low levels. In particular areas, we can afford to keep that at low levels in Europe because we have enough food supply, and we can then also maybe switch to another food supply chain. But that maintains to be a challenge. And then certainly there is among all these substances an endless list of environmental pollutants which are also unintentionally present. There's a large group of contaminants there, which includes heavy metals, which includes arsenic in rice, which includes flame retardants, dioxins, furanes, just to name a few. So it's an endless list. But from a categoric perspective, I think this categorization I've just tried to point out makes sense, and this is also something which the European Food Safety Authority has presented in that particular manner.
I see. And I think in this context, it's worth mentioning that you have written a very well-received book titled Toxin-Free Food. So what inspired you to write it, and what are the key takeaways for the readers regarding food safety?
Yeah, well, I was about to say who inspired me is the mayor of the city of Vienna, but that's maybe a little bit too far-fetched. But indeed, the book is actually a byproduct of my Vienna lecture, the so-called Wiener Vorlesungen. This has then inspired the team organizing this Vienna lecture, and also myself, to also establish this book, Toxin-Free Food, and to write it well in the first place. It was actually a very nice event, and I'm still impressed when I look back into 2022, where we had this wonderful ballroom event in the Vienna City Hall. Well, it was not a ballroom dancing event, but it was in the major Festival ballroom of the Vienna City Hall on the occasion of the 150th anniversary of the BOKU University, where I had the pleasure to give a presentation on toxin-free food. As far as I can recall, David, you have also been a member of the podium discussion.
Yeah, that's right.
To present your multi-class analysis using tandem mass spectrometry. So that was was really a nice occasion. It was, and it's still of important to give at this. That's my take. The consumers an overview of the most important chemicals which are in our food and which are potentially of public health concern. And in order to categorize in a better manner the risks and also the benefits of the food, I came up with that lecture, and then also with a book which is called this toxin-free food, so which is an iteration of the title of my presentation. So what we did is, based on 100 studies published by the European Food Safety authorities, my two co-authors, Chris Elliott and Maria Escola, and I have made an attempt to come up with a chronic risk ranking of food contaminants. And when we're talking about a chronic risk ranking, we have only taking into consideration what is important for the average adult European consumer. So we have not considered sub-Saharan African consumers. We have not considered vulnerable groups like toddlers, infants. And that is why this book is also like just a 110 pages thick. If we would have considered all the other groups, it would have been maybe a 500 page plus book, which nobody will be patient enough to read, possibly. And we also considered the type of critical effects they induce and whether the exposure is regular from foods consumed daily. So that has also been a prerequisite to be for the contaminants to be mentioned in our book. So if you have got time enough, I would like to shortly summarize this risk ranking, David.
Yeah, please.
So who do you think is number one?
In the risk ranking?
The risk ranking, right?
Mycotoxins.
Well, you know, this is, everybody tells me that. Yes, well, as I'm a mycotoxin fan, or something like, I'm proud to tell you the mycotoxin is number one, but it is not number one. The mycotoxins, especially aflatoxins, is number 3.
Okay.
So aflatoxins are genotoxic carcinogens, right? So that's why they would definitely qualify to be number one. However, the exposure in Europe is relatively low. Well, if that's something which particularly occurs in nuts, pistachios, certainly very low levels, but for genotoxic carcinogen, there's no level which is low enough so that you are on the completely safe side. So that's why we have to work according to ILARA principle, as low as reasonably achievable. But then there is certainly also wheat products are contaminated sometimes with aflatoxins, but again at very low levels. But again, genotoxic carcinogen, even low level is a risk, but relatively low exposure, aflatoxins number 3. Number 2, and make it now more exciting, so then coming trying to
step by step.
So number 2 is mineral oil hydrocarbons, especially the aromatic fraction, based on their genotoxicity. Again, genotoxic carcinogens such as acrylamide have shown this effect in animals, and they are number 2, like in front of aflatoxins. Because of their wide prevalence in many daily consumed foods. That is also true for butter. There has been this test that aromatic mineral oil hydrocarbons occur in 90% of all the butter products which are on the market as a result of the machine oil from the alumina packaging which contaminate the butter. And then comes number 1, and that is food process contaminants. I've already mentioned that before. Acrylamide, furanes, also these genotoxic carcinogens, and so they can definitely elicit cancer. And acrylamide, well, if you have your toasted bread in the morning, if you have French fries, so whenever your food is exposed, well, and that's a normal cooking or frying procedure greater than 120 degrees Celsius, and the reaction of reducing sugars with asparagine, an amino acid, causes high levels of acrylamide. So that is definitely these fruit process contaminants. We have a high exposure, and only then comes number 4, like dioxins, nickel, brominated flame retardants, some plant toxins with the incredibly complicated name pyridine alkaloids, which are also genotoxic carcinogens, but ingested only very specifically, for instance, extremely low levels in honey, herbal teas. So to round up or to round off, so without wanting to advertise my book, Toxin-Free Food, too much, I have also to point out that the UK's horse meat scandal, which I have mentioned at the very beginning of our conversation, was investigated in detail by my co-author, Chris Elliott, the founder of the Institute for Global Food Security at Queen's University Belfast, and resulted also in the landmark Elliott report on how to combat food fraud. And who would be more qualified than being a co-author than Chris? Yeah.
Absolutely agree on that, yeah. So, but we can see that there's really a broad spectrum of potential harmful substances which can occur in our food chain, so to speak.
Indeed. It's just sorry to interrupt. It's just the very important, and that has been actually the mission of our book and the major motivation, that it is important to really have a better picture and to put the risks in order, and not just to come up with this opinion or to establish the opinion, well, we're all gonna die from this substance or that substance. So it is okay. There's a hazard. What is the exposure? What is the toxicological assessment? What is the opinion of European Food Safety Authority on that particular contaminant? What are the regulatory limits which have been introduced by the European Commission, etc.? Then you can come up with something like this risk ranking, and then you have like a much better idea and perception also as a consumer. What would be my particular risk also according to the food products I consume, and there's no room for any panic, especially in the European Union, and that is very important to point out.
Yeah, thanks again for pointing that out. And Rudi, you mentioned also at the beginning that analytics play a very crucial role in this broad context of food safety. What advancements in food analytics are you most excited about?
Well, I'm especially excited about analytical chemistry in general, as a professor for that particular topic at BOKU. It is one of the scientific disciplines which has advanced tremendous in pace. We can detect smaller and smaller amounts of chemicals in the food, like in the parts per billion, in the parts per trillion range. We have also, and that when we're talking about fascination, we at IFA Tulln at BOKU, we have the world record, which means that we are able to detect more than 1,200 contaminants in less than 45 minutes based on a tandem mass spectrometric method. This is a method which covers some 500 pesticides which are regulated in the European Union. It is able to detect and quantify. That's a very important aspect, to quantify also next to these pesticides, mycotoxins and other secondary metabolites of fungi, veterinary drugs, algal toxins, and a lot of pharmaceuticals which are also of relevance. Who knows better than you, David, because you did your PhD thesis on that particular topic. So congratulations also on winning the American Chemical Society Award for that particular, on that particular work. However, the bad news for you, David, is that we have now she's not so new anymore, but she's actually about to finish her PhD. This is now a follow-up of your thesis, and now we are able to quantify 1,000 substances in less than 10 minutes. And that is another world record, so to speak. It's really about time matters, cost efficiency matters, as you know better than me, working for industry. And certainly it is also very important to not only detect but also to quantify at reasonable levels of measurement uncertainty, so that you don't have a plus minus of 100%, but you say, well, this is a value with an uncertainty of maybe plus minus 10 or 20%. So on the other hand, toxicology is advancing only very slowly. So as I said before, because there's still cell cultures, often animal experiments, etc., still needed. The consequence is that's the kind of, a little bit depressing in a way when we are talking in the context of that we in analytical chemistry, we can detect so many substances that we know indeed a lot of what is present in our food, which wide range of contaminants, toxins are present in our food, but very little about the toxicological significance. So there's still a lot of research which has to be invested in order to perform improved risk assessments also in the future. What am I particularly fascinated about to accommodate also this question of yours? Big data-based approach. I mean, it's just fascinating that nowadays, before a sample enters our lab, we are now able to perform improved forecasting. So that we have ground truth data of what is which kind of fungi are present on the field, what is the life cycle of the fungi, which kind of genotypes, which kind of maize or wheat genotypes are there, what is the soil composition. We can combine this with actual weather data, with historical weather data, and we have also the mycotoxin data, the pesticide data, etc. And when we are able now in a very fascinating way to combine these with the historical assessments which have been performed in the past, and by looking into the high resolution imaging provided by Sentinel-2, which is one of the satellites in our orbit, so that in the future we just have an algorithm and we have the satellite image, and based on this ground truth data, which I have just mentioned before, which have been measured over a period of several years, we just need this satellite imaging and can already tell at a high level of accuracy whether there is a chance of infection and whether there is a chance of the food being contaminated at levels which exceed the regulatory limits. That's fascinating, and
That's
this is really
yeah.
it's a very impressive thing. Certainly, one can ask, what are we going to do if satellite doesn't work anymore? But that's the same problem with GPS nowadays.
Absolutely.
I'm not too worried about that one, but big data approach is definitely the future.
Yeah, great. And as we wrap up, what final thoughts or advice would you like to share with our listeners about maintaining food safety in their daily lives? How can they contribute to a safer food environment?
Well, these are a lot of questions. Let me maybe start with the first topic on wrapping up what we can conclude also from this whole topic on toxin-free food, etc. So we can conclude that our food is safer than ever before. That's particularly true in Europe. However, clearly toxin-free food is and remains an illusion. So also due to increasingly sensitive analytical methods. So we are kind of, you and me, we're also part of the spoiler gang, so to speak, because we detect ever more and more compounds at lower levels. But I think it's still important to also be aware of these lower levels. So, well, clearly it's an illusion to think of toxin-free food, but safer than ever before, clearly. Another conclusion is that the average adult food consumer in Europe is exposed to a mixture of potentially genotoxic and carcinogenic chemical substances, and that also includes aflatoxin B1. It includes acrylamide, which is more or less daily on your food table. But we also have to keep in mind that the human body has numerous detoxification mechanisms. So definitely, when your genotoxic carcinogenic compound such as aflatoxin binds to your DNA, may cause mutation, may cause cancer. There are enzymes which can cut out this toxin from can cut off this toxin from the DNA. Again, we can verify this because then this detoxification product, so to speak, will end up in the urine, and we can detect this. And if even that mechanism would fail, then there's all sorts of immune cells, killer cells, which can detect these carcinogenic cells. So that is something which is particularly then still a problem for vulnerable groups. That is why I said before, the book would be much thicker if we would address the vulnerable groups where the immune system is not developed far enough, such as with toddlers, with infants, or at older age, or somebody undergoing chemotherapy, etc. Clear recommendation, clearly a balanced diet is the best way to avoid exceeding the daily maximum dose of chemical harmful substances. So that is the major recommendation, balanced diet, and finally to classify the risks. I think it's also when we're talking about to bring the risks in order to prioritize these risks. At least in the European Union, believe it or not, obesity continues to be the greatest health risk in relation to food, and then comes the risk from microbiological food safety hazards, and only third place, still good enough or bad enough, chemical contaminants in food. So final take-home message, if you would like, is this slide on the risk ranking, which I've just presented to you, or not a slide, it's this list. So if anybody's interested in reviewing that again, this book, Toxin-Free Food, in its English version is sold out at the moment, but you can get it as a online, an electronic copy of that, and I think that should hopefully help also all our listeners to prioritize their personal risk profile.
Yeah, definitely.
In a better way.
So yeah, thank you, Rudi, for taking your time and for not exceeding the 1 hour time limit. It was a great fun to talk to you.
Absolutely, yeah. So next time we will sing the Toxin Rock together.
Yeah. Looking forward to that. Thank you, Rudi.
Me too. Thank you.
If you found today's conversation as enlightening as we did and want to stay informed about future episodes, remember to subscribe to our podcast on Spotify or YouTube. By subscribing, you'll never miss a bite of our delicious insights into food safety and analysis. And for those of you with burning questions or lingering curiosities related to our today's episode or any other food safety topic, don't hesitate to contact service at lva.at. Your questions will be addressed either directly in our next episode or by our team of experts on our website, www.lva.at. Thank you for tuning in, and until next time, stay safe and stay informed.